All right. So to start us off, the celestial theodolite, the premise, what is it? Because we got our regular theodolite that we look through and measure things, like during the day, for example, and that gives us variations throughout the day that can't really tell us specifically what the elevation of something like the true elevation of something is, but we can kind of get an approximation thereabouts, right? I think Taylor's found some papers that show that if throughout the day refraction conditions fluctuate, like 20 arc minutes or something like that, which is pretty significant if you're trying to judge something over long distances, right? So what we have with the celestial theodolite is we're removing that variable of refraction of trying to measure an elevation angle between us and a mountain peak, for example, right? What we're going to do is we're going to change things a little bit and use the timing that a star gets blocked by the mountain peak. So we're going to use you could kind of think of it as like we're going to have a big, long telescope that's going to extend from our observation point to the peak of that mountain. And when the star is in the center of that telescope, it's going to be blocked. We're not going to be able to see it. There's going to be no starlight. And we know that, and we know that when it gets blocked, it's being blocked by a physical object there, right? So there's no refraction to account for or adjust or anything like that, right? So we need the specific timing in which the star gets blocked to make the measurement. That's how we're making the measurement. So when the star gets blocked, it is physically occluded by this object, right? So that's going to allow us to determine the elevation of the object that occluded it, like the physical elevation, where it actually is. And so when you do out the trigonometric predictions for a flat Earth versus a globe Earth, when you account for globe slant at the distances that we're talking here, there would be about 200 meters removed from the from Pikes Peak, which would change the timing in which the star would be occluded. So I don't remember what the time is off the top of my head, but let's say, for example, it's 6:27:25 p.m. So 6:25 and then 26 seconds or 25 seconds, whatever, right? Now the globe would make a different projection. It would be like 6 p.m. 23 minutes or something like that, right? That would be the difference in the predictions because that's going to change the angle measurement. That's going to change the physical location of that mountain peak to block that star. So the entire purpose of this explanation, instead of thinking about it from the observer to the mountain peak, think of it like the mountain peak to the star. Because if the timing that star gets blocked from your observation point 50 miles away is the same, then you can logically make the trigonometric argument that from your observation point to the peak of the mountain is the same as if you were standing on the peak of the mountain and looking at that star. Because it's been physically blocked at this point now. Because we're not looking at the starlight. We're not looking at, oh, well, what if the star is over here and the light bends over none of that's relevant. Where the star appears to be, not relevant. We're at the time it gets blocked is the relevant portion. So the proper way for the globularist to address this is they would need to make predictions relative to their location and have timings that match angles that would give the globular amount. Because the predictions during the day for the elevation of the mountain will fluctuate, and when you measure them out, it will give the quote unquote globe prediction, right? But when you measure it at night with the star being occluded by it, that relates to a specific angle. And that angle is substantiated by the necessity that in order to block the starlight, the mountain has to physically be there. It can't be an apparent object that's fluctuating due to atmospheric conditions throughout the day. And then because the same thing would also apply to the star, and then they would have two different corrections. Like it gets preposterous, right? It's one of those things where it's like, you can't get out of this. So if you take the example of like, say, a sugar tank full of water and like a brick to like physically block light, and you had a laser behind the brick a little bit and you positioned it in such a way that the sugar water was refracting the light around it, and you would be able to like substantiate that brick is right there blocking it, right? And then if you move it out of position and you can no longer see the light, then refraction isn't an issue anymore. You've identified that it is now physically blocked by this object. So that is what's being put forward with the celestial theodolite. It's taking the little theodolite on the ground and turning it into a big theodolite. Does anyone have any questions?
I was calling Steven in here because I know he had some questions or something. I always have a lot of questions, but I don't know if Hanson heard that or if Hanson has a rebuttal to that. Jason, I don't know if like you had any questions too about it. So wait, okay, hey, Steven, you're back. Okay, cool. Okay, Steven, Alan is here. He just gave the breakdown of the celestial theodolite. What was your statement that you said when you came out of this room, that we're assuming that the lines are straight?
That's exactly what I said.
What does that mean? Which lines? What are you talking about?
The line, well, you're assuming that the
Can you see Liz's profile picture? We can use that as a reference if that'll help. If you can bring that up.
Yeah,
So
I can see it.
cool. Okay, so when you say the straight lines, where are we straightening that? Give me some locations here so we can figure this out.
Okay. Using Liz's picture.
Okay.
You're assuming that the ground, first and foremost, is straight and level.
Okay.
Making that assumption in this trigonometry problem.
Okay.
You're also making the assumption that the vantage line is straight and straight.
Okay.
Those are the two assumptions in this trigonometry problem.
Okay. So the assumptions, right? We're doing an elevation angle and a distance to give us just a plain trigonometry explanation, right? So we're not like necessarily assuming anything as much as we're just completing a triangle, right? And then we have the globular prediction, which isn't shown in this slide, but we have the same prediction for what the globe would do based on a radius of 3959. So we take the arc sine of that, and we do the distance divided by the radius, which would give us the globe slant, which comes out to be a missing 27 arc seconds, arc minutes, which comes out to be about 200 something feet removed from the elevation angle. So the angle that they predict is actually smaller. So we have two hypotheses like that are mutually exclusive to one another. One would be that the assumption that this flat baseline is the truth, and the other one would be that if this isn't the truth, then the null hypothesis would be that the Earth curve calculation would be the truth. So it's actually not an assumption maybe in the way that you might have thought it was proposed, but this is actually like a null hypothesis. We have two competing hypotheses here. So anyway, with this measurement with the star, at the time that it gets occluded, we can determine which one of the elevation angle predictions is correct. Because only the physical object will block the starlight, and once we see that the starlight is gone, we no longer care where the star is. We just need to know the time that it was blocked, because that will confirm our angle based on the timing and that relationship. If you're looking at Liz's picture, so if you're at the top of that mountain at the time that gets occluded, that's what would complete that angle for that flat baseline, and then you could reverse that back to your observation point logically, because it's just a trigonometric. It is what it is, right? It's a triangle.
Yeah, it's not.
Ooh. So here's the thing: if it wasn't, the globe would have a different timing in which it gets occluded. So it is.
I don't know what you mean. Yeah, what do you mean?
Got you. So in order for this star to line up with this elevation angle for the flat Earth prediction, which would just be the plain trigonometric, observer elevation minus the observation of the peak, and then the distance, right, to get your angle. Right. So when you do the elevation of the star, right, you can see what time it will be at that elevation point. So you can go into Stellarium and you could
the elevation of the star.
Yeah. So this peak is
the angle of the star.
Yes, the elevation angle. So we have this 2 degree 31 arc minute prediction, right? So we can go into Stellarium. We could set our final bearing to whatever it comes out for this lat long here for this distance, and then we could look in that direction, set our Stellarium up at 2 degrees, zoom in all the way to our final bearing, so we're all lined up, and then at the time that a star appears at that crosshair in Stellarium for our elevation, we can go out in the real world at that distance, wait for that time and day, And if that star gets occluded at that time, then that confirms our elevation angle prediction, showing that this flat baseline that we used out of this is the true elevation angle of the mountain. And it's not the elevation angle that's measured throughout the day, which has atmospheric variance to it. And then to make
okay, let me
go ahead.
back to make sure I'm
Yep, you're good. Go ahead. Yes, sir.
Okay, so you're saying there's an app called Stellarium, and it is very accurate at measuring the angles of stars at certain times of the day. Are you
tight?
Are you?
Yeah,
are you
I'm
making notes?
Yes.
Okay. And you're saying that if you're saying that you're using this to test whether or not we can see in straight lines. You're using the Stellarium app to basically test to see if we can see in straight lines or not.
Nope. I'm using this to test when a star gets physically occluded by an object and seeing what time that occurs, and that timing will correspond to an elevation angle for the object to complete that occlusion.
Okay. But you understand that refraction would play a significant role in that.
Ooh, so I do, but here's the thing, right?
Okay.
If the star is physically blocked at that specific time, then there's nothing to be, we're not concerned with where the position of the quote unquote true position of the star is for the light to be refracted over the mountain, right? Because it's already blocked it. So at this physical point now, we're past the point of the apparent position of the star being able to refract over it. And now we've identified at this specific time that this is where the peak is at, because it's now physically blocked light coming from a star.
I truly don't understand.
Yeah. Let me see if I can. So if it's physically blocked at that time, there can't be any refraction, right? Because if it was
have to do with anything, I don't understand why the star has to do it.
Okay, so the star is going to.
Star for?
The star is
the star is being blocked by an actual object.
Okay.
So that mountain peak has to be there at that location, at that elevation, at that angle from the observation of the star getting blocked. So it's really hard for you to get, because it means you have to accept there's a flat baseline under your feet. But for those of us who are willing to understand that everything that around us seems to be flat, it's very simple. The mountain peak is what is blocking the starlight. So we don't care about refraction. It doesn't matter.
Okay.
We're completely alleviating the need to calculate any type of refraction, because the only thing that can block the starlight is the actual mountain peak. The refracted mountain peak is not going to block starlight. So
yeah, it would still block starlight.
That is the beauty of this.
No.
No.
Apparent objects do not block things like that. That's not the way that works. That's not the argument at all.
Can I interject?
We've observed it happening. Do you guys believe in refraction, or you guys don't believe in refraction? I just need to understand that first.
We believe in refraction, but it is overtuned, and one second. There is refraction. It is overtuned, and the curvature of the Earth is caught up in the refraction corrections, because we're showing that with the plane trigonometric prediction and the timing that the star gets physically blocked by the object, which matches the elevation angle of the trigonometric prediction for a flat Earth. When we do the prediction for a globe Earth and account for how much of the mountain would be missing from our observation point due to it being, tilted away from us, that is not manifested. That would give a different timing for when the star gets occluded, because the angle would be physically different. But we have a time that corresponds to a physical angle, which overrides any refraction, because we're looking at the time that it was specifically blocked. So refraction isn't a factor here. Because do you understand?
It is a factor. It's a factor in anything that you look at.
Real quick, so I'm sorry, y'all.
Go ahead.
Clarification from me. I'm sorry. So if the mountain was actually on the globe in curvature, the mountain peak should be lower and the star should be occulted later, basically, is what y'all are saying?
Yes, more time would have to pass because the star would have to get lower in the horizon.
Gotcha.
Space. Specifically, how much time would that be?
I'm not sure I
So
understand. So, okay,
the
you
one
guys
second.
believe in
That would
refraction.
be on the globe to go out
Well,
and
hold
get
on.
that timing down.
We have the timing though. I can give it to him.
I know.
Oh, but yeah,
Okay,
but
so you guys believe in refraction. You believe that atmosphere refracts, right? You guys believe that light bends
mhm.
through long distances through the atmosphere. Do you
Sure.
guys believe that?
Yeah, we're saying that to the tune in
Yeah,
which
do you believe that too?
dude, the argument isn't that refraction doesn't exist. This is a method that allows us to make the angle measurement without accounting for it because it can't be physically blocked by an apparent object. That's not the way it works.
It can't be blocked by
No,
an apparent object.
correct. Nobody would argue that except someone who didn't know that.
It can't be. So wait, but you could definitely have a star if actually under that mountain, right? Under the
Sure.
line, so
Sure.
to speak.
Sure.
You could still physically see that star.
Sure. But what happens when you
Okay.
can't see it anymore? Like that's the distinction, right? Because we're not concerned where the star is. We're concerned with when we can't see it anymore, where it isn't. Does that make sense? Where the star is irrelevant. The time where it isn't
Okay.
is the relevant factor that completes our
What you're
angle.
seeing go away has already been refracted.
Bada bing.
What you're seeing already
But you're
go away
assuming it's a line,
has already
right?
been
When
refracted.
I'm assuming it's a curve.
And it's
We
not
both
where
agree
it's
it's a
supposed
curve,
to be.
right?
It makes sense.
When you say we both agree it's a curve, what doth thou
Yeah.
mean, sir?
The path from your eyes to the star is a curved line. Or do you believe it's a straight line?
Well, we see in curved visual space, the spatial field is Euclidean, right? But we see in curved lines. But the purpose here isn't even that. This is a trigonometric calculation, prediction
Yep.
based off of a distance and the elevation angle.
This is
Yeah,
where we have a
I'm
disconnect.
no,
Any
no. We have, hold on.
done.
One second. We have both predictions though. So we have the globe prediction, which it's a different angle. We predict 2 degrees 31 arc minutes. The globe predicts, 2 degrees 14 or 17, something like that. It predicts a lower angle. So the disconnect
Okay.
isn't that we believe at curved baselines or whatever, right? We have a
Yeah, I
specific
think you're doing the
time
globe
to
calculations
to
wrong.
to confirm everything. Well,
I-
we have a spreadsheet for it, and we've argued it with other globers who
Oh,
have
you
done
have
the
a spreadsheet.
math. Yeah, we've done the math with other
Wow.
globers, and they have the same calculation. So to say that we've done the math wrong without asserting it is kind of like you're kind of like, you're throwing a Hail Mary up, brother. I'm not sure I would take that one.
Hey, can I ask a question? Because I was busy
What's up, brother?
doing something else with the hitting the temperature thing. All right.
No,
But,
Hanson, we're just let them focus on this, and then
yeah. Hold on a second.
because they've come in
Just
specially to
hold on
do
a
this.
second,
I think that
Sebastian.
keep this
Can I
reflected.
ask you, space? So is the problem? I don't know the problem. So bear with me. Is the problem that when you have a star, because of the the movement of the star, and then you have, in the globe picture, you have rotation of the Earth, and then when the star descends behind, let's say you said it's optical obstruction. Is that a kind of mountain or something?
I believe your question is, are we using a mountain to determine when a star gets blocked?
Yeah. So my question is actually, I don't know what the problem is, what the question is. So.
Got you. I'll give you. Are you
understand.
asking me for a quick little recap summary to get you up to
Yes.
speed, brother?
Yeah,
Got you. Okay, so let's start with a null hypothesis, right? Let's say the Earth is a globe, right? That's going to be our null.
Can I? I'm kind of guessing. Can you see what if my guess is correct? Is that right? Maybe that would be faster.
No, it's
I don't know how it would be faster if you guess wrong and don't know based off of 2 seconds of me speaking.
Yeah.
Cool. So we have two separate predictions, right? We have a prediction for a time in which a star will physically vanish from us based off of it being blocked by a peak, based off of a globe prediction where the peak is going to be slightly lower because it's tilted away from us, versus a flat Earth baseline prediction where it's just going to be plain trigonometry. We have two separate angles which give two different times for for when the star would be physically blocked. So now that we have the time and the angle, we go out and we look at the star and we see that the time that it gets blocked by the mountain physically matches the time that we predicted for one of these two outcomes. And it matches the outcome that is the angle for a flat Earth prediction. So that's the kind of summarize.
Actually, cool. That's actually matches matches my guess. So basically, you're saying because the flat Earth, we know the elevation of the mountain or the peak of the mountain. It actually will appear higher than the what the globe Earth would predict, because it's curved and it's kind of sinking a little bit below. I mean, lower because it's tilted and bent away lower, right? And then so the angle. The elevation angle for flat Earth should be higher. I mean, when the star is obstructed, should be higher than the globe Earth would predict. Is that correct?
Absolutely, sir. And that corresponds to a time in which the star would get occluded earlier than when the globe would predict that the star gets occluded, because it has to get lower. Right.
Yeah, I mean, whether the movement of the star or the rotation of the Earth, you estimate it's uniform angular speed, and
yep.
It will be the globe Earth would predict a later time for the star to descend behind the mountain peak, right?
Yes, sir.
Okay, so your your measurement, you're trying to say that the measurement is actually earlier, matching the flat Earth better than the globe Earth.
Yes, sir.
Is that correct?
Yes, sir.
Okay. And what is the error in measurement time or angle? Is that
Ooh, good question. So you could get in. So the accuracy of this is dependent upon the timing. So you could add plus or minus 1 second, which will add, I forget the arc minute relationship there. I will have to get the specifics on that more. But what you can do with this, like, this isn't just like the one measurement. You can use other stars, different locations. So you would air bar like plus or minus 1 second. And then
can I put
go
it
ahead.
in degrees, because the time and degree, it should be equivalent, right?
Yeah. Absolutely.
So angle, right? So if there's angle, the obstructing angle in the flat Earth, if I read it from the Elizabeth profile picture, is 2 degrees 31. What is I forgot the name for the arc or something. 31 arc, the prime.
Arc minute.
Arc minute, yeah. 2 degrees 31 arc minute, and then what would be the prediction of the globe Earth? Is this mountain like actual mountain, like 2,074 meter elevation? Is that an actual mountain?
Yeah. Yes, sir. Yeah. 1 second. Hey, Kat, I sent you a Google Doc link. Can you put that in the chat for everyone to reference? So I have a nice spreadsheet calculated out, so you can reference this too. That's what I just pulled up for this. So for the globe angle predicts 2 degrees and 19 arc minutes for the elevation between the observer and the mountain peak, and that's Pikes Peak in Colorado.
Oh, Pikes Peak, and so it's the 31. So basically, it's the flat Earth is 31 arc second, and then the globe Earth is 19 arc second, right? That's the difference.
Yep. Well, the globe Earth is actually a little less, but then they add refraction in, because this is like. So when we do the calculations, right, the flat Earth prediction is just the raw trigonometric angle based off of the elevation difference between the observer and the mountain peak and the distance. So whatever that comes out to be, whatever that changes. So for Pikes Peak, it comes out to be 2,226 meters, and then the distance is 50,700 meters. And that gives us the 2 degrees and 31 arc minutes for the angle between them. And then when you do the same thing for the globe using the arc sine, just basically just dividing by the radius and the distance over there, that gives like 2 degrees and 4 arc minutes, something like that. And then you add refraction to it. So for us, we ended up just using celestial refraction, which is 15 arc minutes. And you could do it the way that Ruhif does it. I don't know if you know him, but you can do you can do a calculation slightly differently, where you use the terrestrial refraction and then it adds 2 arc minutes to it, which comes out to be 2 degrees and 19 arc minutes. So they give the same agreement, just different refraction and way to derive the slant, so to speak, to get the thing. But anyway, when you apply the refraction corrections, you get 2 degrees and 19 arc minutes. So you have to assume and make corrections for the globe prediction, and that's for during the day. And then that would, so if that's what they're saying that it is during the day, then Stellarium would say the same thing. And then when you move the observer to the mountain peak, you would have to add another 15 arc seconds for the refraction at the peak, and that would give you 2 degrees and 46 arc minutes if you were at the peak. So the globe makes 2 separate predictions that aren't manifested, actually, and they require corrections. Go ahead.
Summarize. So basically, globe makes, but you there's one point you said move to the mountain peak. I'm not quite sure what that is, but let's get to that point later. So let's say we're still. I mean, I think the observation is on the ground, right? The observing point initially, right? And is it on the ground?
Yep, that is where we are doing our initial calculation to get the baseline for everything. Yes, and that is where we're observing it with the timing. Yes.
Right. Two scenarios. One without refraction, and then without refraction, the flat Earth would be 2 degrees 31 arc second. Is that correct?
Arc minutes.
Arc minute. I don't know what the name is. So let's get rid of the 2 degrees, right? We're always going to be 2 degrees. So let's just for the sake of convenience, not speaking on that all the time. So sure. 31 arc minute, right? Flat Earth, and for no refraction, 31 arcs minute, and with the no refraction and globe would give you 19 arc minute, right?
Okay, let's see. So the raw globe, the raw globe. Thank you. The raw globe with no refraction predicts 2 degrees and 3 arc minutes.
And then wait a second. Globe with no refraction would predict 3 arc minute, right?
Yep.
And then
if you do the arc sine calculation that we did, like I said, you could do a slightly different method and get, like, I think it comes out to be 214, and then you add 2 arcs, and then it comes out to be 217 or something like that, and then you add 2 for the terrestrial refraction, which comes out to be 219. But either way, it's going to be either 217 or 2.3.
Do you have a link to the map you did, like the spreadsheet?
Yes, it should be in the Clubhouse.
Yeah, Beasticles put it in the chat, Steven. You can look at it.
Yeah, that's fun. Yeah, I'll fact check the spreadsheet and I'll make a copy and I'll get back with you guys.
Cool. I can send you. My buddy actually did. If you want to independently verify this as well, my buddy did the ECI to ECEF coordinate transforms to make sure that the elevations for everything was right. And I can send you. Actually, that's a PDF. I can still send it to you though if if you're interested in that as well, to go over his work.
I think this is. We'll start with this.
Okay.
And, we'll go from there.
Do you have the locations? Like, I mean, I would love to look if you have any other presentations on this. But do you have like the actual like the geographical location of the vantage point, latitude and longitude, and stuff like that?
Yeah,
Is
we
that in
do.
there?
Yeah, we do absolutely. So the way that the observation works is that if you put the information out there for your thing, you'll dox yourself. So if you the guy that did this did it from his house because he can see everything from his house, but you would be able to like backwards derive what it is, but I can give you I can tell you how to do it, and then you could figure it out.
Hey, Space.
What's up?
I got a I promise I will fact check this.
Yeah, no worries, man. No
I
worries.
would love your
do you have
opinion.
real quick? Let me give you my email because the easiest way to contact me if you're not on Discord would be by email. If you want to exchange communication that way, my email is AlanSpaceAudits at
Just
gmail.com.
put it in the chat just so I'm
Oh, right. Yeah, I can type that actually. 1 second. I got you. AlanSpaceAudits gmail.com. There we go.
How do you explain the link that I put in? It's like a flight from Sydney to Johannesburg, taking only 14 hours. How do you guys explain that? Like a flight you could buy and go on and like take. That happens like all the time.
Oh, my bad. My mic was muted. Hold on a second. So the argument now is flight routes on projected on an AE map using straight lines and how they don't work. Is that what you're saying?
They wouldn't work if it's if it was a flat Earth.
Got you. So
what do you guys?
So all distances on the graticule, right? Anything that uses latitude, longitude in the northern or southern hemisphere are symmetrical. So the reason that the flight routes look different is because people draw straight lines on the map, and then they are like, "Well, it would never work." But when you plot out the thing with the graticule is that it is invariant under transformations or different projections. So all the distances computed, if you apply the correct correction, you will get the correct distance. Like you'll get the correct way that it looks. So although it looks like it's huge and skewed and big, and like the distance is different, it's the same exact distance. It just looks that way. So we don't argue that everything is that skewed like that. That's not our argument. If you're using the graticule, it's symmetrical.
Like that flight.
So if you go to ADL, if you go to go to this website, adl.place. Let me know when that pops up. I'll tell you the next step.
Place.
Yep. And then you'll see a thing that says Shane's database.
Okay.
When you go to Shane's database.
Okay.
Type in, there's a little search bar. Type in, what am I looking for? Maps. Type in the word maps, and you'll see a subtopic come up that says maps and the coordinate systems they are projected from.
Okay. I can't do that.
Actually, I got a better one for you. I'm going to put this in the main chat for you. Yo,
can you just give me the...
I got you. Beast, are you there? I'll give you a direct link. I got you. The reason I have to do it that way is because I'm on an emulator, so I can't copy paste directly into the chat like a long link. Well, I'll have my friends do it. So anyway, just click this link and you can see what the actual argument is. It's a symmetrical coordinate system, so there's no difference. It just looks messed up because of the way it's flattened out. When you use the correct tool to plot it out, it's the same.
Here's the problem.
There's no problem.
Okay.
But continue.
Let me
go ahead.
Let me explain. Is I picked the location of Sydney to Johannesburg on purpose. Okay. It's ridiculously long on a Gleason map, right? It's like goes from like basically one end of the Gleason map to the other, right? It also involves going north, like across like India.
Yeah. So let me,
right?
if you don't mind, you've already ignored what I said about how it's not a problem and how it just looks more skewed than it is because it's flattened out. And when you apply, it's like all distances on it are symmetrical. So if you're looking at straight lines or you're looking at the curved line for it, just know that that curved line, even though it's bigger, represents the same distance in the north. So when you go to that website that I linked earlier, you can see that the argument that you're making is irrelevant because you're arguing against the globe while believing in the coordinate system that substantiates it. So
I genuinely don't understand what you're saying.
I know.
Check it out, bro.
We know. We've been trying for weeks and months.
Go ahead and click the link that I posted. All right.
I clicked it.
Okay, cool. When you're looking at that, basically what you're saying is that it doesn't work on the AE map. The AE map is a globe projection. It's just a projection of the graticule, bro. It's the same exact coordinate system.
Okay, so I'm talking about maybe I'm misunderstanding. The flat Earth model believes that the Earth is flat. We're assuming the Earth is flat, right?
Mm-hmm. With you so far? Yep.
I'm asking you.
I'm with you so far.
The Earth is flat.
Mm-hmm.
And the shape of the Earth is the same as a Gleason's map. Do you guys believe that or not?
Circle, yeah. Mm-hmm. Sure.
No, I mean.
Okay,
yes,
well,
but no.
Okay, well, I'm hearing yes and no.
Yes.
Can I interject just a little bit?
It's just a coordinate projection.
Hold on. Let him go through his line of questioning first, real quick. Go ahead.
Let me just ask Space.
Yes.
So you believe, because I can only deal with one opinion at a time.
Yes.
Right.
Yes.
So you believe that the Gleason's map is what the Earth actually looks like from a bird's eye view?
Pretty close, right? Not exactly.
Okay, close. But close.
Yes. Yep.
Okay, fine. Close is fine enough. Okay. If you took a flight from Sydney to Cape Town, you would, the fastest way to get there is a straight line on the Gleason map, correct?
No, that's not how you use a Gleason's map. Straight lines on a Gleason's map do not work that way.
But
you have to use
a straight line on a Gleason's map is a straight line in the real world.
Oh, no, bro. I'm saying I'm saying that the coordinate system that you're referencing, right, is the same in the north as it is in the south, regardless of what projection you're looking at. Because all it is, right, you can actually replace all, like, think of the AE map, right? And then
when you say AE map, do you mean a Gleason map?
Yes.
Okay.
Yes. You're good.
Okay.
You're good. Yeah. Think of the old Gleasons, right? And you see all that land on there, China, Russia, America, all that. Imagine all that's gone, and there's just a snapshot of the positions of the stars on the vernal equinox.
You lost me.
Well, latitude and longitude are all defined by positions of the stars, and all the map is that we're referencing, right, to traverse the land is positions of the stars. So what they have is a symmetrical coordinate system, right, that completes a ball. So if we have a northern hemisphere and a bottom hemisphere, or if we see in a hemisphere and we pass the equator and we map the southern hemisphere, right? We have, either way we slice it, we've got two hemispheres, right? We merge those together. What do we get? We get a ball, right?
You don't believe in two hemispheres, though, right?
Well, I believe that we see in a hemisphere of vision. And if you were to map that onto a coordinate system, you would have positive values in the north. And then when things go out of your field of vision, you would map that as a negative value. So whether or not it goes beneath ball curve or eye curve, so to speak, it would be mathematically mapped the same. So what we have is a symmetrical coordinate system that relates the positions of the stars to the ground. And then we're not even going to get into the corrections and stuff, right? We're just going to take it for what it is right now. But the symmetry is what we're focused on. And now we're going to use that to navigate and plot routes. Now, the beauty of this spherical coordinate system, once we've merged it together, is we can project it onto any other shape. We can make it an azimuthal equidistant. We can do the Gleasons. We could do equirectangular. We could do a Mercator. We can do whatever we want, right?
Yeah, I agree. You can.
Right?
But
right?
I'm asking you based on, like...
So hold on. Hang with me. So we've got a symmetrical coordinate system of positions of the stars to relate locations on the ground. And then when we're just looking at it from an AE projection, it looks skewed, it looks different, right? But it's still the same. It's still symmetrical, right? It's the same coordinate system. It's the same lattices and longies.
There are still latitude and longitude. I'm just asking you which one you think is real. Which map? If you think that the world is 2D, right, and maps are 2D, which map is right?
So how do we? Right. So how do we substantiate between which projection of the graticule is correct? Because all we have is the coordinate system. You're asking me, how do we know which projection of the coordinate system is correct? Is it the globe projection? Is it the AE projection?
Which one do you
right.
believe in? I don't even care about proofs.
I believe it. I believe that the AE map best represents the interpretation because it is flat.
Okay.
And when we use the select, well, all maps are flat, but they all use a spherical coordinate system, so that argument's irrelevant. If you understanding what the latitude and longitude systems are, saying that all maps
uses a spherical coordinate system too.
Correct, but it represents
spherical coordinate systems.
Right, but it represents outward concentric circles for it. So that is what my position would be.
Okay.
So
we agree that you believe that the it's not perfect. We agree that it's not perfect, but it's the closest we got to the actual map of the real world.
Well, it's all any of us have, and all it is a position of the stars.
Okay, whatever. But you think that you're putting your money on the Gleason map being the closest we got to what the real world looks like.
In terms of the layout, yeah.
Yeah, okay. So if you take Sydney, Australia.
Oh my God, dude, you're not listening, bro. It looks like it's longer. Symmetrical coordinate system. That's the last time I'm going to do it. If you don't get the argument, longer, then peace be upon.
I can have a ruler and every scale.
Yeah. Yo. Okay, hold on 1 second. Steven, there's a video I want you to watch, right? If you're truly don't understand this argument, I want you to watch this video that my buddy Shane made going over the Gleasons real quick. And he goes over the straight lines, what the little ruler things are doing, how to calculate distances. And I promise you, if you watch this video, I'm not going to promise you, but it should help you understand my position better and how the position that you're arguing is like nonsense, not a good position to argue. Not a good position to take.
You just don't use straight lines in the Gleason's map. That's not how it works.
Hold on, I know, but he's not gonna accept that. Hold on 1 second. Send him this.
Measuring the length of meridian.
Beast, if you can, please.
Determine the difference in latitude between.
And then.
Please don't sleep on.
I forgot.
No, I'm just saying, if you are interested, bro, like, he goes over it exactly how the Gleason's map is used. Like, there's a reason why, if you've seen a Gleason's map, it has that, like, little ruler attached to it in the center. Like, have you ever seen that?
It's to calculate angles. Listen. But how we use it is specific to the Gleasons. It's to calculate angles, not draw straight lines in the way that you're doing it. It's a time and sun position calculator. So you should. Hold on a second. I know. Please. Just watch that video because you're about to make the same reference again, and I don't have the patience to listen to it again without you know what I mean.
About to say, don't sleep on the fact that this has all been very well explicated and explained.
Can I interject? Sorry, because this is fascinating. I really wanted to get back to the celestial theodolite, and Stephen, I think you've been fantastic, listening to the argument, but remember that you have been given the spreadsheet to go away and have a quick look at, and also you've been now given this coordinate system. So maybe could we get back to the celestial theodolite maybe with Hansen, because for me this really is the crucial thing, because this is
absolutely
something new.
I'm going to give it the time it deserves. I'm going to fact check it and get back with you, but I'm not going to do it right now.
Awesome. Well, we can come back to the graticule stuff later then or something.
Yeah. I was going to ask real quick, Alan and everybody here from Ether Cosmology, what's up, homies? Are we able to do possibly, I know that I had asked Kat the week before, maybe we can do another Ether Cosmology and Flat Earth gang like hang out and maybe have Dr. Mike come in here and Taylor of course, and just like kind of go over the backstory and everything, just so that we can have it in a recorded session, and that way we give the opportunity for some of our other Globers to
Absolutely. Absolutely.
I know
I'll
it's been a
send
minute
Mike.
since we've done
Yeah.
Hangout, but I really would love to do this in a recorded room. Unfortunately, we cannot turn on replays once the room is recorded. I know that sometimes having the replays on, it deters people from wanting to have the conversation, but I feel like with something like this, something new like this, that's Celestial Theodolite, having Dr. Mike come in here, tell his backstory, having Taylor come in, you guys in a recorded room, maybe we could plan something for next week. And those are my 2 cents, and y'all can continue. Thank you.
Well, it is actually being recorded because I heard Space say that he's screen recording. So I think that's fantastic that he's
No,
doing
but I
that
just mean
because
for the house, Sebastian,
oh,
for us
sure,
to have
yeah,
like an
sorry,
actual,
thank
like
you.
to have an ether cause FEG chill sesh, how they call it. Corey will get us with the cool PTR AI PTRs, and we can make it a thing for next week or the following week whenever y'all are free.
Nice. Sounds awesome. I'll send Mike an email and see when he's available.
Yeah, reach out to me on Discord. I can definitely join.
Yes, Taylor, because I know you're part of the story that he helped you out with that, and I just feel like the story's incredible. I think it's awesome because there was never you guys had any dog in this fight to try to do this. Like Dr. Mike wanted to help you, and then in him helping you ended up coming into this realization. So I just think it would be cool to just be able to give people the opportunity and time to ask all of these questions, and another chill sesh. So thank you guys.
Cool. So I'm gonna be quick because I have to go pretty soon. So Sebastian, you wanted me to read out the formula I use.
I'm not. Hanson, can we do this at another time? I'm really more interested because there's individuals in here that are want to deal with the celestial theodolite, and that's the thing that I'm most interested in. So if you've got, if you can, refute the argument that Space is making, with all due respect, I'd much rather hear that right now than.
Okay, so hold on. All right, fine. Because I just give a key point, right? And you can we can do this another time. But I'll give you the
I'm not. With due respect, like
dude, he is not trying to hear you out at all, brother.
Earlier. Let him rock, Sebastian. Let him get his question out. He said he got to go.
Yeah, just please address what Space is saying, and then when he's gone, and when the other people have gone that are not dealing with the celestial theodolite, we can talk for at length about what we were talking about. Okay.
Okay, fine.
I'm not talking about it right now, if that's okay.
That's fine. All right. So what is Space saying right now?
Nice, dude.
Giving you the argument.
Yeah. Was there
back and forth with him?
Yeah. Did you have a specific question, Hanson, or something about the celestial theody?
I picked up bits and pieces because I was doing something, the estimation of temperature. So you're saying because I think somebody, is it Steve?
Yeah.
I was asking the path of the flight path, right? So you're saying that.
Good Lord, all right, man. All right, hold on a second, Hanson. It's been real, Hanson.
Theodolite, please.
Yeah, we're staying on task with the celestial theodolite. We're not talking about that. Steven threw that in there because he was getting frustrated with the conversation, so he wanted to move the goalpost. I specifically asked them to come in here to just explain this because I was having a hard time explaining it, and I know that we're all just trying to understand. So again, and I don't want to take up their time.
You're good. I'll just give a quick recap. This guy's not listening at all, but just to help make people or help understand it and help give some arguments that some Globers have put forward to try and like straw man it, right? So remember, the important thing to remember out of this is that there's a specific time for the star to not be there anymore, regardless of refraction or what model you think you live on. There's a specific time that corresponds to when the star isn't there. That's all we care about. And that time that it's not there matches the time that would give the corresponding angle to the raw flat Earth prediction with no corrections. That is the important part. And the second important part to 1 second, dog. And the second important part to this is that the globe has a different timing prediction. So if we only have a timing prediction that matches the flat Earth prediction, then we could logically draw the conclusion that the timing of, that would be necessitated by globularity isn't real. It's not a real calculation. So that's a really important thing to like understand the baseline of the argument from, because from that point on, they're going to try and say, well, what about if the star is over here, refraction, and you're not accounting for it? We need to do measurements of the mountain during the day. What angle is it during the day? What about the angle between you and the mountain? Like what would stellarium say for the observer at 50 kilometers away from the mountain and that star? Would it give the same angle? It's like, no, obviously not. That's not our argument. The argument is that the timing that gets occluded for the mountain peak, if you were to be at the top of that mountain peak, you would be like instantly teleported, and your theodolite or whatever you're doing to observe the star being occluded would have the same angle that you're looking at your observer point. That is the argument that we're making. When that star gets blocked, specifically, when it's no longer there, that is what completes that relationship where we have that straight line from that star to the mountain peak all the way down to the observer. That's all an instant snapshot in time based off of when it gets occluded to complete this argument. That is the only time in which those will match up. And that's what completes the angle for the top part. So if you were to go to the top of the mountain, this is what all this is relevant to at that specific timing. If they make it about anything other than that, they're not playing right. They have to substantiate the globe timing.
Okay, sure. Yeah. So basically, so we continue the question I asked before. So I see that you have on the flat Earth, the angle is 31 arc minute, right? And whatever the 2 degree. Let's just it's a
sure.
It's already there, right?
Yep.
31.
Mm-hmm.
All right. Okay. So and then the globe Earth is 15 degree arcs. 15 arc minute, right?
Yeah. If you do the raw, depending on how you do the raw calculation for it, for which refraction you're going to add to it, we could do. The only reason I'm prefacing this is because of the straw man argument that will be forthcoming later. But you're good. You're good. So yeah.
So basically, it's a two by two matrix, right? So we have refraction, no refraction, and then flat and globe, right? So it's 2 by 2. It's 4 cases, right? No refraction on the flat. It's 31 arc minute, right? And then you said no refraction on globe. It's 3 arc minute. Is that correct?
Yeah, 3 arc minutes for the raw globe.
So with refraction, flat is how much?
With refraction isn't the necessary component for our prediction, right? We're doing the raw calculation.
I understand.
Yep.
Yeah. So no.
You could add it, I guess. It would just yeah.
Yeah. The flat Earth does not consider refraction. That's fine. So on
hold on. It's not that we're considering it. It's two. It's two separate It's two separate predictions, like for the raw calculation. Because if we did raw globe, you'd never match, right? So this is supposed to. Yeah.
No. Because
I got you. It's not that we don't believe in refraction. This is eliminating that as a variable. Go ahead.
Sure. No, I understand. So I'm just filling out this 2 by 2 matrix, right? So with refraction, flat, it has no data, right? It's not right? So because it's not considered, right?
Mm-hmm.
Okay. So with refraction on globe, did you say 19 arc minute?
Mm-hmm. Yep.
Okay. Cool.
With refraction, yeah.
And, right. So.
And then you gotta add one for the peak too. When you go to the top of the peak, because
go to the top of the peak. Okay, cool.
Yeah, because the measurement is about when it gets physically blocked, right? So you could kind of conceptualize that as being instantly teleported from your position at 50.
Exactly.
Right. So when you go to the top of that, you got to add another 15 on there. So you're going to be at 2 degrees and 46 arc minutes for your peak prediction.
Peak prediction, that is with or without refraction?
With always
With
with.
refraction. Okay, okay,
Yeah.
cool. And then, so did they actually go to the peak and measure that the peak elevation?
No, what they did is they used stellarium to predict when it would get occluded based off of those angles, because you can toggle refraction on and off. So with stellarium, you will get the prediction of 2 degrees 31 arc minutes on that peak. And then when he measured it or measured that timing at his house, he confirmed that triangle, right? He confirmed that elevation angle of that peak matches the flat Earth prediction, which would correspond to 231 for both at the top and to his location. Go ahead.
Yeah, but it'd be great that I mean, so the 46. I mean, actually, there's no measurement made at the peak. Is that correct?
Correct, but it is not necessary because, again, we're not concerned with where the star is apparently after the fact, right? We're concerned with that specific time where it gets occluded, which is going to draw that straight line to it.
No, but the
Gotcha.
thing is that would be great if at the same time the peak elevation is measured, right? Because that would be different for the different for globe Earth at the same time, right?
Can I respond?
Go ahead, Taylor.
So, like, whenever you're doing a theodolite measurement of something,
and
you're
then
gonna stand at your point of observation and measure the height of it, but the angle of the star would actually be different on the peak compared to looking up at the peak.
right. I mean that's the point of globe, right? So because the horizon is bending away. I mean, not horizon. I mean, the Earth
When you
so
when
you
you
have
put
a
the
large-
when you put the observer in
large
stellarium there, you get the same, and you have refraction on. You get the 2 degrees 46 arc minute prediction. So it gives like this. It gives the same correspondence, but what we're showing is that the angle without the refractive condition shows the true elevation peak of that peak because that's where it gets physically blocked.
No. I mean, it is blocked. What I'm saying is the if you measure from the peak, the angle at the same time when it's blocked by the peak for the observer on the ground would be much larger angle, and that would would be a more decisive measurement.
It doesn't
doesn't-
change anything. Like,
Why not?
Because it already got blocked at that specific time. Like that's the beauty of this.
Oh, no. But
Like
the thing
what
is, if you
what
say
I know, like
if
what
you're
you're
on
trying
the
to
peak-
do by making it about where it is after the fact, though, that's not relevant.
No, it's not after the fact. I mean, you can do it at the same time, right? So you put on the cell phone or and then say, hey, okay, 3, 2, 1, make the measurement. So at the same time, somebody on the peak can do the measurement, whether it's 46 arc minute or is it or is it 31 arc minute, right? So that would give you a larger difference than the 19 versus 31 arc second, right?
Yeah, it's going to give you 46, bro.
Yeah, exactly. So 46 minus 31 is like 15 arc minute. The others 19, 12. Yeah, I mean, so I mean, right. So that will give you a larger discrepancy, right? To see who's right?
We already know who's right.
Well, we are trying to determine who's right?
Already did.
What do you mean?
If the star got occluded at a different time, then it would produce a different angle.
Yeah,
But it doesn't.
I mean, you're avoiding my question, right? So I'm saying that if you
No,
put the
you're trying to make it about
measurement
where the
on this
measurement.
peak-
Dude, you're trying to make it about where the star is after the fact.
what do
It
you mean?
gets physically blocked at that time
block
by the
for block for
Yes.
the observer on the ground, right?
yes,
Yes.
which tells us what? So we're instantly teleported to the what?
What do you mean?
To the mountain
something on the
peak. To the mountain peak, right?
Yeah, I mean, you put two.
That
observers,
is
right?
that
One
is That is why the angle matches. That is why when you turn on refraction, it goes to 246. There's two separate predictions here.
Right. So
we already know where the star is at. You're trying to make it about something else.
No. It's made at the same time.
Jesus
right?
Christ.
So you have,
I can't.
When the star is excluded.
I know, he's just kind of going in circles. Like,
Listen, Hanson, it's been a pleasure speaking with you.
Yeah, don't avoid it.
I mean, if I, your mic's, Gally, your mic is horribly messed up. I already answered it though, repeatedly, and then we're like back at the same thing because this is what has to happen, right? Because no. Listen. Hold on a second, real quick. Hanson, listen up. Listen up. Remember when I started with you need to have a timing that matches the globe prediction, otherwise they're going to try and make it about things that it isn't. This is you doing that.
Which isn't. I'm saying post two people on two different places, and one on the peak and one on the ground, and make the measurement at the same time. So what's wrong with that?
This is like telling the Globers whenever they're doing their theodolite measurements that whatever they're measuring, they should have another. Hey, chill, bro.
Because the star isn't in that position, bro. It's apparent. That's why we're using the mountain to block it. That is what confirms the angle relationship. Yeah. That is what makes it. Stop. Yeah, but isn't the but is what's getting you. Yeah, that's it. That's just hard cut it off. I'm only angry. I'm only getting angry because we've gone around about 4 or 5 different times now. It's not going anywhere.
Because you're not answering the question. So
I can't answer it any harder.
People at 2 different places, but make the measurement at the same time. What's wrong with that?
Hanson, what was the first thing? What did I start with, Hanson? What was my original opening premise? Your conclusion was my premise, dude.
Yes.
And now you're saying, hey, why are you getting upset? Because you're not paying attention, Hanson. And we're going to conclude this episode of Celestial Theodolite. If you would like to hear the answer 4 times, you can listen to the playback.
Well, you're not answering the question. I
already answered it. The answer to your question was my premise, brother.
What premise?
Exactly. So you need to stop. Like, I'm done now. It's over. I'm done now.
Thank you for coming. Where can we listen to the playback? Because this is getting silly now.
It'll be on Space Audits YouTube. So if you go to space_audits, that's where it'll be.
Excellent. Thank you very much.
Question.
Yeah, Hanson, it's already been answered, dog. And if you keep doing that, like, I'm just going to hard ignore you.
Yeah,
he's just like subtly, constantly talking in the background.
Yo, Gally. Yo, 1 second. Yo, Beast. What was the answer to the question?
I don't even know. What was his question?
He's trying to make it about the position of where the star is after the fact.
It doesn't matter. We're using the timing of it. Like, it's the time when the star gets occluded by the mountain peak. All right. It's very simple. Flat Earth prediction, 2 degrees, 31 arc minutes. Okay. How do we confirm that? Let's use a star, right, that gets occluded by the peak of the mountain. Hey, look, it gets occluded at that time, exactly at that time. How can we confirm that angle then? Let's put the observer on the peak of the mountain. All right, we put the observer on the peak of the mountain. Let's look at stellarium. What does stellarium say about the elevation angle to the star from the peak at that time? Hey, look, it says 2 degrees, 31 arc minutes without refraction. GG.
Correct.
GG, good game.
Yeah.
Awesome.
Correct. But if you look at the globe Earth model, then they will predict at the time it will be 46 arc minute, right? That would be different.
That would make the star above the mountaintop, and then that would be included then.
Dude.
Yes, exactly.
Yeah,
but it physically was, dude. Because listen. So Hanson, do you understand now? Listen, this is the significance of making it about after the fact and where the measurement isn't, right? So this is why the argument that you're making isn't relevant to what we're putting forward.
Not relevant because because your prediction, if you go to
Okay,
the
this is getting
flatter,
silly.
the
I
angle
can't.
would be
Yeah.
Please,
31
is there anyone else that
in
wants to talk
the
to
arc
Space?
minute.
Please,
All
At
right.
the same
can't
time,
make it any more
the
simple.
Is there
the,
anyone
the
else?
angle on the peak would be
Yeah,
31
Is there
arc
anyone
minutes.
else? Yeah.
Listen, bro.
Okay.
Sorry, Hampton. I'm not trying to
I
be
don't
rude,
know
but
who did that.
I don't know how many
Wait,
times you can go
did he? Wait,
round
okay.
in circles here.
You get a 5-minute break, Hanson. Just
Oh, okay,
think
that was
through it.
Brandon. That was
No, that
Oh,
was
it wasn't me, but
that was me.
he needs a break because
That was me. That was me.
you know people
Real
are
quick,
obviously getting upset,
Heated.
and
Yeah.
patient.
Does anybody
So,
else have any questions? Hero, you have been silent for a
Yeah,
while. Do you have any
I have a
questions for
question.
them?
Yeah, so the person who made this observation from their house, were they measuring the angle, or were they measuring the timing, or both?
Calculated the
What's the
angle.
significant thing?
So he did a measurement during the day of the angle with two different instruments. One instrument, he said he got 231, which would be the flat Earth prediction during the day, and then again during the day using a more precise instrument, he got like what would it be, like 217 or 219, I think it was. It was pretty close to the globe prediction, plus or minus like 1 arc minute or something like that. And then when he did the celestial theodolite, that is done by calculating the angle, and the measurement is done with the timing specifically for the confirmation of the angle. Because you can,
So the timing.
Yeah,
So
go ahead.
I guess my I'm having a hard time like trying to figure out what this proves. The timing is something I can't really
Gotcha. So
like replicate, right? Like it's something he did. He provided the timing. How did he record the time?
Yeah,
what
so
did he use for that?
His took time lapse footage and then just using your cell phone time, I think.
All right. So the other point that did you say that you used for the flat Earth prediction, you didn't apply any refraction correction, but for the globe Earth prediction, you did apply a
Correct.
refraction correction?
Correct.
Okay. Why didn't you do them both the same way?
Well, the purpose is to establish the true position of the like the true elevation angle of that mountain peak, right? So if we're going to compare it, right, we would do what the raw elevation angle would be versus what the assumed refracted correction would be, right? So we have two different ways to compare it of where the physical location would be, just to calculate it out, right? So you need to do one raw to have the comparison to, right? So when you do the globe, you do the slant, then you do the refraction calculation to get what the prediction would be. And it comes out to be
like changing your method.
Well, no.
On
Well,
one
no.
versus the other.
Well, no. So check it out.
Suspicious to me.
No, how so? We're seeing so here's the thing, right? How are we going to get the globe timing to confirm the angle, right? If we don't account for what the globe predicts and how they would make the calculation. Because if we do 2 degrees in 15 arc minutes or 4 arc minutes, depending on how you calculate it out and which refraction calculation you use to add the globe to it, you're not going to get the timing that the star gets occluded, because that's like the actual purpose of it, right? Because that's going to tell us if the physical elevation of it, that's going to tell us which calculation made the correct prediction. Because if it's the globe, then the mountain has to be lower, so it's going to take more time. More time has to pass for that star to get lower, so it's going to be a different time. That make sense?
I mean, it seems like you could apply that logic to your flat Earth prediction too. So
No.
Mutually,
They're mutually exclusive to one another, bro.
Leaving it out is fine. I mean, sometimes it's simpler to leave out.
Okay, let me ask you this.
It's probably a small adjustment.
Yeah. So do you understand that we're trying to see when it was physically occluded? So we need to know, like a baseline would be like, okay, let's say that we're not even going to account for refraction. We're just going to say like, what time does it get blocked at? And then for the globe, we have to figure out, what the physical elevation of the peak is going to be. So we could use either calculation. We could do no refraction for the globe and you're still going to be off, or we could do the proper refraction for the globe to get the elevation angle that they say that's where the physical peak is at. And now we're testing which physical peak prediction is correct, the raw flat earth calculation or the raw and or globe corrected calculation for the physical peak.
Can I describe it a different way that I think they understand it? So like that we're trying to see if like the mountaintop matched the flat earth or globe earth prediction. And because of refraction, things will actually change throughout the day. Like they'll see things get shorter throughout the day. And so we want to know, okay, is this mountain actually there? Is it actually there? That matches the flat earth prediction, which is what he measured, right? So then we're actually looking to see if it's actually occluding a star to confirm, yes, the mountain's there, and yes, it matches the flat earth prediction.
Yeah, I mean, this is why this is so important, because this is the first time this has been done. And this is why I'm so interested in it. So thank you to everyone involved.
And if you're wondering, like, I do have some papers that I posted that show how things actually get shorter throughout the day. There's been multiple times it's been documented with mountain peaks and hospital buildings doing long time-lapse footage, basically tracking the height of things throughout the day. And we'll find that things throughout the day, because of the temperature gradients on the ground that the sun produces, makes things get shorter throughout the day. So we want to say, okay, well, the mountain's actually much taller at night, and this is what multiple peer-reviewed papers have found as well. And then, is it actually there? You know, is it actually there, which matches this flat Earth prediction? Well, yes, it's actually there because it's actually physically occluding the star. Do you see what I mean?
When you say it
So,
gets bigger,
so it's
you mean
basically
it
the same
appears bigger, right?
argument from Glober is that refraction is raising a physical object out into the distance, either to occlude or be able to see.
Can you add Piezio to the speakers, please?
Add who?
Piezo.
Oh, Piezo. I got you right now.
Yep.
Yeah, I just invited him up. So what was my can I ask Liz real quick? Was my explanation, my layman's explanation, pretty spot on about what's going on here or not?
Yes, this morning. That's what I'm saying. The only thing that I got confused in is because when I went in last week, Shane had corrected me. I was like, oh, then it would be higher. And he's like, no, it would be lower. So that's what I was just trying to like get. But I think Taylor explained it well too. But yeah, no, Jose, you weren't wrong. It's just like, you know, once Steven threw in there like, oh, you're assuming that the lines are straight. You're doing this, you're doing that. Oh, here's a flight path from Sydney to Johann. Now we're just like, okay, what are we doing here?
Yeah, that dude, he was flailing hard.
Yeah. All right, cool.
Hey, can you guys hear me?
Oh, what's up, Piezo?
Yes,
Hey, what's up, guys? So I listened to the entire exchange. I just wasn't able to actually speak because I wasn't home. But so this happens all the time. We lay
Every
down
time.
case, and then they say, well, why don't we just get two observers, one at the house and one at the mountain, and get two measurements and see if they match? In fact, that is not only is that not our point, that's the opposite of what our point is, because our point is if you did that, you'd see two different angles at the house and at the mountain. Of course you would. You're in two different locations because wherever you see the star is apparent. That's the entire point. If we were to take a visual angle measurement at the house and a visual angle measurement at the mountain, they would not match. We're not even claiming that they should match, right? The point is that whatever visual angle measurement you make is an apparent position. It's not a true position. So, and that apparent position is influenced by refraction and all types of other things. And so, in order to eliminate all the visual stuff and just make it a raw measurement, you incorporate the mountain blocking the star. Then, when you use the mountain to block the star, we know that mirages don't block things, right? A mirage of a mountain would not be blocking a star, right? Only a physical mountain would be blocking a star. So wherever that star gets occluded must be where it really is. So that's why the actual relevant measurement is not any visual apparent angle. It is the time that the star gets blocked. Because if we take that time that the star gets blocked from his house and we teleport ourselves to the mountain in Stellarium at that time, we will get an angle to the star from the mountaintop that matches the angle to the mountaintop from the house if you were to be using plane trig and a flat baseline. So the flat baseline plane trigonometry angle to the mountain based on distance and height is the same angle, raw angle from the nautical almanac to the star from the mountain at the exact moment that the star is blocked by the mountain from his house.
Yeah, and I think this is the beautiful part about this. Can I ask the people involved in this, what pushback have you had so far? Because I can't see anything wrong with this at all. Nothing whatsoever.
Just straw
Pretty
men.
solid, dude.
Just
Yeah,
we
just
ha-
straw
Just
man.
yeah, like
sure, yeah.
yeah, like I said at the beginning, the only way to properly address this would be to have timing measurements that correspond to globe angle predictions, and that hasn't even been attempted yet. All anyone has ever done is try to measure the angle from Mike's house to the mountain during the day. Things like what Steven was saying, like introducing another observer, which would different angle. It's not what we're talking about. Um, the only way, and it's not like, and he might not even be intentionally doing that, right? Like he might be trying to like make sense of it because he's like, well, if we do this and that, like that's not the argument though. So like, you just kind of have to understand that it's only about the timing and it lining up with that when it gets occluded, which would correspond to the angle that would, create that flat baseline for you to get the same angle all the way across.
Yeah, it's just 'cause I
Go ahead.
don't consider. I apologize. Sorry, I don't consider what I've heard, in this room from Stephen and the other chap pushback. It was just, going around in circles and introducing straw man.
I was just gonna
And
say
I'm,
that
I'm talking about other people. Sorry. Yeah. Go
I
ahead.
want you to know why they're going to be different angles. Like, whoever's on the mountaintop, if they were to be measuring it, would be a different angle because in different locations you have different angles to stars. So it would not exactly match what his angle would be. Because as you move to different locations around the Earth during the nighttime, you're going to have different angles. So that wouldn't even matter. But it's the same thing as us saying in any of the Glober's theodolite measurements, why don't you have 5 other people out there confirming it? Why don't you do a measurement from what you're observing back to the observer just to like double check it? But it's even worse because the whole point is to see when the mountain occludes the star. Like, so you wouldn't need somebody on that mountain too. That would be defeating the purpose, and also it would give a different angle measurement anyway.
We've even had Ruhif be comfortable with adding 2 different refraction coefficients, one from the observer to the peak and one from the peak to the star, and being cool with that. Like they're totally, it's crazy.
The mountain is the magical. The mountain is the distance, the variably distant scaling magical midpoint at which the 2 refractive indexes converge every time.
It's the convergence point of 2 refractive.
And the cool part is, you guys can literally do this with any mountain peak that you want.
Right. Any mountain that you want at any distance you want for any star you want, it will always automatically scale with you to become the magical midpoint for the refractive index convergence.
So wasn't that one of the pushbacks, is that it was just like, oh, then it has to be coincidental, but it's like that's the whole purpose of why some of y'all are going to go. I know that Alan and Kat, they're going to try it too, and if we can get more of us involved to do this, think about it, from different locations, from different atmospheric conditions, obviously not a super cloudy day, then we all know that in mathematics there's only so many coincidences until it's not a coincidence. So again, observable, repeatable. I'm willing to work with a glober, I'm willing to work with Alon the non-earther, I'm willing to work with anybody on this, because again, this is something new, the kinks are being worked out, and I appreciate you guys coming in here, because I know Jose and I were kind of going back and forth, a few of us were kind of just like talking about it, but that was the whole thing. It's just like the observer on the mountain peak, to measure that angle back, that wouldn't do anything. That's not the whole purpose of it. We're not measuring the angle in that sense. We're just trying to capture that moment in time when that star is blocked by that mountain.
Yeah,
correct.
to confirm the mountain's position too. And I posted the paper in the chat that shows how things get lower throughout the day. So this could be some of the reason for discrepancies in the globe or theodolite readings, like why they get things that are shorter. We find that things get shorter throughout the day. This has been documented many, many times. And it's like so baffling to me. People don't know this if they're doing like theodolite readings and they're actually researching this stuff, right? So we can actually confirm, yeah, the mountain is right here where it should be and the exact height it should be on a flat earth. And we can double check and just make sure it's not some weird refraction anomaly because the mountain's physically there because it's literally occulting a star. It's like really simple.
Yeah, the refractive index or standard refraction rather, right? Also, we none of us can test the fact that refraction exists. Everyone's watched time lapse videos of a bay looking across water from one shore to
Skunk
the
Bay.
other, and yeah, and seeing what happens. And no one's denying refraction's a real effect. What we're saying is that ultimately, right? Like if you were to really trace it back, if you were to say, how do they know how much standard refraction is, right? Like they made formulas to calculate what it should be, but how do you confirm it? Well, you confirm it through a reification. You presume that you have a globular baseline. And so any measurements that you make as they optically deviate from that baseline have to be corrected. And then you just average out a whole bunch of those corrections and then you get your standard refraction. And then you use that as, oh, this is where how much refraction happens everywhere all the time on Earth on average.
Mm-hmm.
But
Exactly.
but that's not a proof, right? That's what it would have to be if it were a globe, right? That's what that is. That's not actually a standalone, objectively validated thing. And so in our position, that's the reason instead of arguing all day about refraction, because that argument will never end, let's say we're just going to find a way to eliminate the need for refractive corrections because we know that refracted mountains don't block stars. Physical mountains do. So let's just measure the time it blocks it and trace and force the line. And that's what we do. That's what this experiment's doing. It's just a fancy way of forcing the line.
Mm-hmm. I
Well,
describe it a little
hey,
bit there. I take a different approach to describing it than other people, so I hope that I'm not like, making it confusing. But yeah, and I also just posted a paper like about how refraction is much higher during the day. So if you do want to take a measurement, it should be at night. There's much less temperature gradients during the nighttime, making any measurement more reliable.
I don't know, guys. I think, you guys are saying refracted mountains don't block stars, but they've been claiming for years refracted mountains are blocking the sun, with like candle and stuff. So I don't think they're gonna have any problem refracting that mountain wherever they need it.
It's pathetic. So pathetic.
Yo, refraction reveals things in the distance that curvature blocks. Now it blocks refraction blocks stars in the sky.
LOL.
I went and Googled it, and his name is Eratosthenes.
Eratosthenes.
Eratosthenes. I think you got
Oh goodness.
Yeah.
Oh,
Funny how Globers never know their own people's names.
and just to be clear, to answer to what Lisbeth said, you are correct. They would have to claim a coincidence. So they're actually, if you're a globularist and you're intellectually honest and you're logically consistent, there are only two positions that you can possibly take regarding these measurements in order to try to maintain your paradigm and remain logically consistent. The only two things you can say are A, the timing measurement was wrong. They measured the wrong time, or B, it's just a cosmic coincidence. And actually, A would still be a coincidence because if they measured the wrong time and it came out being what it would expect to be on FE, then it was just a mistake plus a coincidence. And B is just a coincidence that just happens to work for all mountains at all stars at all distances. And it variably scales all the time everywhere. So there's not really an escape from it. And when I pointed this out, there was a presentation on this given in Earth Awakenings and Geo's Discord, I got cussed out for it. I got cussed out for putting people to to making a point out of it and saying, okay, was this time wrong or is it a coincidence? Right. And then people get very angry when you pin them in a corner with only two logical options. But I mean, it's true. That's the only two options you have to be logically consistent as a
Okay, well,
globularist.
I'm new to this idea of a flat Earth. So how did
Apparently.
this gentleman debunk himself?
I mean, if you take for
What?
granted that it's actually a historical thing that happened, he only had two wells or sticks, whatever the story is. So it's just not enough data points to say anything conclusive about. Could go either way. You could have
You
gotten the
talking
same
about
exact results
Pretty
from
Eratosthenes?
much.
Eratosthenes.
Yeah, he's talking about
Yeah, I don't
Eratosthenes.
think we had that part of the conversation. We're not going to go that far back into this conversation. Let's humor that right now, to be honest.
Yeah, we're
Well,
talking
people
about
are
something
saying
totally
he debunked
different.
himself.
Yeah,
No, I
Yo,
don't know
Eratosthenes
Stick,
how this
is.
argument
Joyce,
started
cash
because
in your
everyone
pink
knew the
ticket
world
and
was
come back
round
in
before
another.
him. So
Hey,
he was one of the last people to figure it out. So how did this
hey,
happen?
Well, no,
Lucifer, chill out real quick, bro.
Eratosthenes is actually a circular reasoning argument as well. People don't realize that
100%.
because in order for that to be true, right, he would have had to know the precise distance between the two cities in separate, countries or whatever, however many miles away they were. I don't remember how many miles.
It's
It was like 400 or
500.
600, 500 miles. Okay. So it's like 500 miles apart, right? But he would have had to have known objectively precisely how far apart they were. But the way that people measured distance was using celestial navigation and presuming a shape. But how could they presume that shape if they didn't know what shape it was? So it becomes inherently fallacious, psychologically circular. So
Yeah,
it's like it's in question whether that any of that's even real or not, because how would he have even had the distance baseline to presume upon it in the first place in order to make a trig measurement with parallel light rays that don't make sense in the first place?
Because
Hey,
people have been navigating by sea for tens of thousands of
ooh.
years, and they
Using
use the
Okay.
stars.
All right. One
yes,
sec. Let me
yes,
let,
and the
let me.
orbits and rotations around a spherical modeled Earth would get their ships to the right coastline
Luz, I
repeatedly
tell
and
you what, Luz,
consistently.
look, check it
Can
out,
we
Luz.
get back
They
to
can't
Cash in your
use
pink
the
ticket.
flat
celestial
Earth
theodolite if
model.
anyone's got any
I'm,
Real
I'm
quick,
trying to,
hold
questions.
on, I
I'm trying
got
to,
you,
I'm
Luz.
trying to
getting
land on
kind
the
of
point.
crazy in here. There's a lot of
I'm trying to
mics
I
land on
open.
the
got it.
point that the
Hold on,
sailors figured it out
Luz,
before
Luz,
him,
Luz. Listen, hold on. I got it,
generations
Brandon. Hold
before
on.
him. He was the last person to figure it out. That's the
All right,
point.
Luz. Trying to get a handle on this here. Cashing that pink ticket. I would love to humor your conversation and all your curiosities. We're just like way past that part of this. Like no one's going back down to that level to have that conversation at this point. We're
Yeah,
like
I want to go
onto
even further
something
back
totally
because
different.
clearly people haven't had the conversation.
Okay.
Nah,
They fucked
dude.
it all
Well,
up.
if you won't be respectful, just move you back to the audience. But I'm giving you an opportunity to come back anytime and just talk about this whenever, man. I'll gladly walk you through, our treatment of all of that stuff. But this is not the time at all. We're
Hey,
talking
dude,
about
save your
celestial
fucking energy,
theodolite.
dude.
Yeah,
I've talked to Luce before, dude. He's a lost fucking cause.
clearly
I
coming up here
promise you.
talking about Aristophanes.
So can I ask Space a question before I gotta go about the topic? Hey, I got your spreadsheet. I copied a few of these links. Is there anything else? Does you have? I mean, that graphic in Elizabeth's PTR comes from something. Is that like a presentation? Is there anything else I could?
I'll post the
Any
link
other?
again for you, bro.
Yeah, I
Okay.
can I can send
All
you
right. I'll
some
take a look at this
PDFs
later.
from them
My
that'll walk you through it if
gut
you
is
want.
telling me that I don't like including refraction on one side and not the other. I think you should either include refraction on both or not do it on both. But that's where that and the timing thing is where my biggest questions are. But I'll be glad to take a look at this stuff more. I'm glad you guys are looking at stuff. That's commendable.
Would it match the globe prediction if refraction was off?
Like,
Is that what you're
so
saying?
so you said you had a question in there?
Oh, you're breaking up a bit, bro.
Well, no, I'm not making a claim. What I'm saying is
You're lagging super hard, bro.
if you make a correction, it's gonna. So if you're doing that on one side, not
You're
Can y'all
matrixing
hear
in
him?
and out.
Yeah,
Nah,
You
he
got
you're
you got
matrixing
the
in and
lagging.
Traffic
out.
is
He
water,
got
dog.
you got to
crazy.
check your connection.
Were you out in
let's do
space?
it.
Pastor Van Halen about.
Galactic rays are coming in.
Should we give Hero the 16-minute clip from Glowbusters? To maybe help him out.
How to like reproduce it or whatever.
So Hero's big thing is that he thinks it's suspicious that one side is including the refraction and one side is not. So I think that that's where
Yeah,
he
it's like a
was stuck at.
misunderstanding of the argument, though.
Yeah, Hero, can I quickly ask you a question? Are you open to the possibility that Earth may not be an oblate spheroid? Are you open to that possibility?
Let me help you out. Hero is not open to it.
Facts.
So, with all due respect, I think this is just, pointless. If you're not open to it,
No, Hero is actually the person on stage. I would love to hear. I'm surprised. I would love to hear him pipe. He's the refraction guy. You know what I mean? He's been standing on. Yeah, this is so well understood. It's all refraction. He's the refraction flattens out the globe guy. He's been standing on that
Dude,
very matter of factly, very
you know what's
confidently for a long
you know
time.
what's crazy, bro? When you look at that spreadsheet I posted, so there's some pink highlights in them. And I'll tell you what the dark pink highlights are. So you see the dark pink highlight says globe slant 27 arc minutes. We see here that the difference at the bottom dark pink one, the difference from the globe for the observer to the peak and from the peak to the star is also 27 arc seconds. And that is made up by the refraction coefficient that is added to both predictions. So the globe exists as a refraction correction.
So let me ask you, Space. So you guys did not perform the measurement on the peak, right?
Oh my gosh.
Are you serious, Hanson, bro?
Yeah,
Hold
I'm
on, hold on,
serious.
hold on, hold on. Hanson, do
Did
you
you not,
understand that?
did you perform it or not? I mean, that's a simple question, right?
Hanson, do you understand that even if they performed the measurement on the peak, that it would be different than the measurement from his house? They're not agreeing. The measurement from the peak and the measurement from his house do not agree optically. Like the measured angle visually with your eyeballs to the star is not the same on the mountain as it is at the house.
I mean, if it is on the globe Earth.
What?
No.
If it is on a globe Earth,
Wouldn't in
the
either.
measurement will not be
Yeah, they're not the
Jesus.
same in either.
Let's let
if it is
Piezo
on a
cook real
flat
quick.
Earth, if it is on a flat Earth, the angle would be the same at the same
What?
time.
Dude.
Yeah,
The
so
stars are
with
in different locations, even among each model. You're
No,
not going to
if
see
it is the
Polaris from
same
the southern
star, if it is
hemisphere.
the same star, right?
so once again, the apparent position and the true position are different. The nautical almanac that Stellarium is programmed with, if you turn refraction off in Stellarium, it gives you the nautical almanac position of the stars, which is the true position. Then you can turn refraction on to see where you would actually see the star, which is the apparent position. So where you see the star and where the star is are said to be different. That's
Okay,
why
so let
it's
me
not
let me
about the measurement
yeah,
of the
let me
angle.
understand this, right? Because I think it's the spreadsheet is pretty helpful. I mean, the spreadsheet they pasted in the chat. The spreadsheet about how they did all the computation on this flat Earth without refraction, right? And then when they did do computation as without refraction, the peak, the angle for the star at the peak is exactly the same as the angle measured on the ground, and that is actually in the spreadsheet. It's I think that's correct, and I don't know what you're saying. I mean,
It's
if we
not okay.
just deal with the
Can I
flat
correct?
Earth without
Can I clarify
refraction,
this?
right?
Can I clarify this?
Yeah.
Okay. We need to make sure we're consistent with our terms. Okay. The angle measured from his house. When I say measured, I mean like looking at the star with a theodolite. What does the crosshair of the theodolite say on the readout? That angle is not the same as the angle measured from the mountain to the star. Those two do not agree. When we say that it matches the angle from the house, what we mean is if you use a flat baseline, you pretend that there's not a curved ground, you pretend that there's just a horizontal plane, right? So you can use triangles, and you use the distance to the mountain and the height of the mountain and trig, you predict an angle of 231, okay, which is different than the angle on a curved baseline, because the angle on the curved baseline is like 217. So they're different, right? And one person might say, well, let's measure it and let's try to figure out what the refraction is. And we say that's too hard. Let's make it much simpler. Since the two values are different, right? The angles are different. What we will do in order to try and prove the flat baseline, the horizontal plane, is we will use a more distant object behind the mountain and wait for the mountain to block it. Because if the mountain
Yeah, I
blocks it,
understand all that
there
part,
that means
right?
there's a
So
straight line between all 3 points: house, mountain, and
yeah,
star.
no, I got you, right? So my
Okay.
question is, if you look at the actually the spreadsheet is very good. The left in the diagram, right? It basically draws the flat Earth model, and then the right diagram draws the globe Earth model, right? So basically this is just geometry, right? So on the flat Earth, and we're not taking the refraction into account, and so the angles measured at the same time when the star is obscured by the mountain peak for the person on the ground. The angle on the ground is 2 degree 31 arc minute, and then the angle on the peak is also 2 degrees 31 arc second, right? I mean, do you agree with that or not?
So the angle to the star from the peak with refraction turned off is 231, and the angle to the mountain with refraction turned off from the ground on a flat plane is 231. Those two numbers are what matches.
Correct. We agree. Right.
Okay.
So if you go
So
to,
that proves our point. I don't understand where you're going with
okay,
this.
so the point is, if you go to the right diagram, and when it's globe Earth, the angle on the ground is different, and in fact less than the angle on the peak. Do you agree with that?
Yes.
Okay.
Yeah, that's the point.
Yes,
That's the
exactly.
point.
That's the point. Exactly. So it's on the peak, it's 46 arc minute, and so I was just asking if the measurement have you, or the person, whatever, the have you performed the measurement on the peak at that time?
Okay. Follow me really carefully right here. All right. When you just asked, have you performed the measurement from the peak? You cannot perform a measurement to an unrefracted angle. Any measurement you take is going to be a refracted angle. That's why we use stellarium, because it gives us the nautical almanac value. If we go to the peak and point our theodolite at the star at that exact moment, we're going to get somewhere around 246, not 231. But the almanac gives its true position, which is 231. So it makes no sense to ask, have you measured it from the
Okay. So
mountain?
how about this? Let me phrase my question this way. Have you at the so just I mean, first question, have you performed the measurement? I mean, it doesn't matter what the just the active measurement, like taking the angle of the star, whether it's parent or
The measurement that he took
Let me
was the
get
time it was blocked for the
yes,
50th time.
right,
That's the
but
measurement.
it's the measurement
oh my
performed on
gosh.
the ground or on the peak?
On the ground.
Okay.
Stellarium performed the measurement on the mountain. So we have Dr. Mike's measurement from the ground, Stellarium's measurement from the mountain. Those are your two
Wait. When
measurements.
you say stellarium measurement, you didn't actually perform the measurement. You just did the
Okay, hold on.
computation.
Wait. Okay, freeze right there.
Computation or
Let's
measurement?
nip this in the bud real quick. Let's nip this in the bud. Do you contest Stellarium's accuracy?
I
Yes
don't
or
know
no?
what is stellarium. I mean, are you looking up a table?
Okay, I
Are
just
you
told
doing
You
a
you.
don't know what
computation?
NASA putting out. You don't
Hold on.
question NASA that way.
The only reason that it would make any sense to go any further in this conversation along this line of reasoning would be if you disagreed with the accuracy of Stellarium.
No, I don't know.
Stellarium is literally, hold on, Stellarium is literally the globe model with the nautical almanac. So what it does is it takes the true position of the stars from the nautical almanac, it factors in your elevation, and then it allows you, if you want, to factor in refraction.
I
You can turn
understand.
that on or
Okay,
off.
so you're doing
Okay.
computation, right? Did it a
Dude,
computation?
the
There's no person.
true position of a star is always computation. You cannot
Wait.
measure the true
Okay, so
position
let me.
of a star,
Okay,
Hansen,
so that's a question yet
with
to
the
be answered.
theodolite.
That's the question yet to be answered. Okay, so my question
No, it's
is,
not. Do you disagree with the nautical almanac? Hold on. Do you disagree with the nautical almanac? Yes or no?
I don't know.
Okay, if you
Right
don't
now,
know, then you should go study astronomy and leave this conversation until you can walk into
so
a room
my
with the big
question
boys.
is, my question is, was a person on the peak at the time that
Hansen,
the star
Oh my
was?
God.
Hansen,
Yeah.
Was there or
do
not?
you disagree with the nautical almanac?
I haven't
Yes
seen it.
or
I don't
no?
know. So
It's a
I'm just
yes or no
asking
question.
what you
If
did.
you don't know, then you're not ready for this conversation, bro.
I am just
just
asking
take a
what
seat
you
back, bro.
did. Okay, I'm just asking what you did. All right.
Do you know what
so
stellarium is?
The stellar, whether stellarium is true or not, that's a different question.
Do you
I'm
know what
asking
stellarium
what
is?
You did. All right. So was there a person?
The nautical
that
almanac
went
has been
up
built
to-
from about 400 years of astronomical observations all the way around the world.
Okay, that's a different question. Okay. Whether I
Okay,
accept
so
or
the
not.
nautical almanac is what tells me that the true position to the star from the mountain is 231. I got that from the
That's a
nautical almanac
computation,
there, buddy.
right? That's a computation. My question is, was there a person that
Hansen,
on
there
the
have
We
been
know that answer, bro.
thousands
Was
of
there-
people, not
Yeah,
one
yeah,
person,
that's
there have
whatever.
been thousands of people for hundreds of years measuring the angles to the stars.
Okay. I mean, they could be wrong. They could be right. That's not the
Okay,
question right
so
here.
if you don't have a
Right now.
position, then you can't participate in the conversation. You need to
Why
take a
not?
position.
I'm asking the simple question.
You're asking
Was there
dumb
a
questions.
person
Hansen,
on
very
the
dumb
peak
questions.
We've answered that
at the
10
Hansen,
time
times.
of the
okay,
occlusion?
look, I'm going to get a yes or no answer from you, or I'm going to stop this conversation.
I'm asking you a yes or no
Do
question.
you agree with the nautical almanac, yes or no?
I don't know.
Okay, I'm done
I
talking
haven't
to you.
seen it.
Goodbye.
So can you give me a yes or no question?
Dude, we have
Was
answered
there
this
a person
100
You are
times.
caught
on the
dissing
peak at the same
Yeah.
time
so
when the
hard.
star was eclipsed?
Dozens of times.
The answer lies in the nautical almanac. How about that, bro? Check it out. Look into
that's a
it. Let us
computation.
know.
I was just asking,
We
was there a person
Let us know.
doing the measurement?
Hansen, can we move on because we're just going
Yeah,
around in
this is-
circles here?
Because you're not answering the question.
No, dude, you're cog dissing hardcore.
No, they were
Nah,
not on the
Hanson,
mountain.
you can't say they're not answering the question.
They are not.
I've heard them
because
answer the
I'm
question
asking,
several
was
times,
there a
bro.
person on the peak?
No, for the
No.
20th
Okay.
time.
Great. Fantastic.
Gosh,
I got my
we have
answer.
literally said
The
Hanson,
nautical almanac was
Hey,
on the
wait, guys. He got his answer. Are you going to remember it this time?
Yes. So there was no.
Okay, moving
person on the
forward.
peak, right?
Continue.
No person on the peak, right?
You forget? Did you already
I
forget?
literally just answered. He
I'm
asked
just
me again
confirming.
already.
Did you already forget?
I'm
Oh my
just
gosh.
confirming.
Yes, you did.
All right. Well, we're done with you, dog. Have a nice day.
We're
Yeah,
done with
because
you too.
Hansen, if
Why
you
are you
don't
so
have a
angry?
position on the nautical almanac,
It's triggered.
this
I don't know.
conversation is
It's a
pointless.
simple question.
Are you a
With all due
science
respect.
denier, Hanson? Is the nautical almanac wrong? Is stellarium wrong? Oh, you're a science denier, bro.
I don't
He's
know.
either lying about being college educated or he's being purposefully obtuse. Those are the only two options.
Well, that's
Is my microphone still suck?
This is his MO.
much
No, you're
about
good.
your
Just a
logical
slow learner.
capacity.
Oh, my microphone's better now?
You want us to engage with you, and you couldn't even answer if the nautical almanac's
What's up?
reliable or
What's
not.
up, Gally?
Yeah, that's kind of the thing, Hanson. It really it does feel like time wasting if you don't really even have a position.
Yeah,
'Cause you don't even know how you feel about this.
this is time wasting now. Is there anyone else that wants to ask questions?
Hanson,
Yeah, I have a
you are
question
the
about
weakest link. Goodbye.
the celestial
Well,
theodolite to
you're no
space.
link at all.
Space. Hanson, hang on. We don't need you to obfuscate anymore. We can tell you don't understand. Space audits. Is that your name? I have a question for you.
Go ahead, sir.
So you don't believe in refraction?
Hey, man, I bet if you went to the mountain and measured it, it'd be a different angle, you stupid flurf.
Oh, my God, dude.
Oh, dude, what a stupid
Did you take
argument.
a measurement from the mountain? So stupid.
It's really bad, dude. Okay, so
It's just it
real
manifestly demonstrates his
But
lack of
lads,
understanding.
we've been through a lot in this last 2 hours, right? And
about to go to the
let us not forget the most important part of this. It's about the time that it gets occluded and where the star isn't. It's not about where it is, and they will always try to move it to another location because they can't deal with the
reality of it.
yeah, they can't deal with what it is because they don't have the same time. If let me put it like this: if they had a timing that gave the globe elevation angle, it would be significant globe like it would be bad.
Yeah, and isn't the even using the occultation times predicted by the globe for his house, isn't they're like 3 arc minutes apart. Like the star is like 3 arc minutes. It's like 3 or 4 arc minutes different than the mountain. So the occultation time should be different by like how many seconds is it per arc minute? Multiply that by 3 or 4.
60. So what is that?
Yeah, it's
100,
like
180 arc seconds or something like
half a
that.
minute. It's like 15 to 30 seconds different for the globe than it is for FE. I can't remember exactly what the time is, but I could figure it out real quick. I'll meet up.
So real quick, just for the layman and for me, just to understand it, you take a mountain, right? The elevation of a mountain, and you have your distance, however far away you are from the mountain. The farther away you are, the better because it extenuates. It makes that straight line way more apparent. So you can take any mountain peak of your choosing, use stellarium to basically figure out which star would get occluded by that mountain peak by using your initial bearing and then having your final bearing. Um, and yeah, you can use any mountain peak and you can have just a plain geometry prediction, right? From your observer location, right, where you actually are to the mountain peak, boom. And then you confirm that with the mountain peak being occluded by the star at a specific time. And at the exact same time to confirm it, you have that exact same time. Now you put yourself on the top of that mountain peak using stellarium. And then when you use an uncorrected refraction angle to the star, it matches every time. Not just once, every time. He did it with Blodgett Peak as well. It's crazy.
So real quick, I was gonna ask because I came in late. I was just wondering how many times like the gang has kind of replicated this because I remember hearing Ruhif saying that he's just gonna bank on it was done wrong, right? That's kind of the best I heard him come up with last I heard him talk.
Yeah, Ruhif is the snake who has really no argument, and he's
Yeah.
comfortable with adding two different refraction coefficients. Like, and that's ridiculous. Like,
Well,
yeah,
and check this out. For every different mountain and star combination that you use, right? For every, or rather just the mountain, because the stars, it doesn't matter which star you pick. But for every different, mountain distance and height that you use, you're going to get a different differential between the globe angle to the mountain and the globe angle to the star for that location. And so that causes for every different mountain height and mountain distance a different differential in terms of timing as well. So it's about 4 seconds per arc minute that the sky moves. It moves about 1 arc minute per every 4 seconds. Dr. Mike had a time lapse camera that was, taking images, I think once every half second or once every second. I can't remember which one of those it was, one of those two. And uh, or no, it was a video, but he's time lapsed it into that quality. But he measured it accurate to within plus or minus half a second. You can round it up to 1 second. It doesn't change the fact because the differential is like 3 to 4 arc minutes, which is going to be 12 to 16 seconds. So he's accurate to within at least like a second, right? I mean, he's got GPS time on his phone, so 1 second would not change that much, but the differential for the globe is 12 to 16 seconds. So the timing difference is where it's actually important, right? And if he checks a different mountain, it'll be a different timing difference and another timing difference for another mountain. But for us, it just always works out. Weird, right?
And to the question, Dr. Mike has done this with multiple stars at both of the peaks that he has been using. So 6+ stars. I'm not sure of the total number, but he has done this multiple times at both peaks. So coincidence has long been tossed out the window. But like Piso was saying, the more locations, the different locations, different mountain peaks, the more repeatable, the more undeniable that these observations stack up to be.
I just want to say thank you to everyone involved, to the people that started it, and to the people here that are explaining it fantastically well. And I can't see any issue with it at all.
Yeah, we're gonna plan to do like a recorded. Oh, my bad, Taylor.
You can go ahead first. It's okay.
No, I was just gonna say again for the room, we are planning to, maybe get Dr. Mike, and again, shout out to you guys at Ether Cause, and do a FEG Ether Cosmology hangout sesh. Get Dr. Mike in here and go over the backstory of this and how it came to be and so forth. And now that links have been provided in spreadsheets to some of the Globers here, they have time now to look at it so that when we do this in a recorded session here, whether it's next week or the following week, we'll all coordinate, we'll all figure out the logistics. Then there should be more further moving along in this conversation because they would have had the time to look over this, and maybe we can kind of just cut through the crust of the things that we're banging our head against the wall on both sides. I mean, and I'm speaking for myself, like, just on my version of understanding and so forth. But yeah, I really do hope that we can do this and yeah, just have all questions answered then.
Yeah,
What's your question? Is sorry, I apologize. Go ahead.
Yeah, I was just gonna say that, one of the things I've heard as a response is, okay, well, why are the Globers measuring the mountain in different locations? And, I provided 2 links that you can respond to them with if they say that, because they're basically saying, oh, Dr. Mike's reading was wrong because they would measure the mountain here and we measure it here. Well, I have 2 links to respond as to why that could be and why that most likely is because we see a consistent drop throughout the day and much more refractive variation throughout the daytime measurements versus the nighttime measurements. Those temperature gradients along the surface of the Earth will actually even out. And I posted a paper to show that. So the more temperature gradients that you have on the surface of the Earth, you're going to have more refraction. But during the nighttime, those gradients will become steady and you have much less refraction. So if you want to have a more steady measurement, do it at nighttime. And so basically this is why they found multiple things shrinking throughout the day. So basically what I heard Ruhif say was like, okay, well, we measured the mountain here. Why did he measure it there? And I would answer, look at these papers. It's because the refractive variation is much more during the day. And you actually see this atmospheric compression increase throughout the day where things become steadily shorter. Yep.
So you're telling me the objects in the distance, like mountains or anything, is optically compressed during the day, and we're not going to get its true position necessarily? We would have to use some other methodology, like doing it at night and using a star occluding it.
100%.
Nice. Hell yeah. Well, I'm glad we did that. That's what's up. Is that my boy Tony Coriolis I see down there? Tony C?
Yeah, that's me. What up, Alan?
What up, dude? Can you do me a favor? I have a presentation tonight, and if you want to send me like a nice selfie of you, like, doing thumbs up or something, Tony Coriolis may make an appearance in the presentation.
I got you, man. Where should I hit you with it?
Send it to me on here.
Okay, I got you. Yeah, no problem.
Awesome.
Love it too. Sounds great, man.
Yeah, I'm about to leave and go finish working on that here in a minute. So yeah, just send that to me whenever.
What is it on, Alan?
Oh, it's a follow-up presentation on inertial forces and where to find them. So the week before last, I did a prezi on what an inertial frame is and how it's defined and all that stuff, and how it's just been defined through Newtonian mechanics and relativity theory and all that. And then this week, it's going to be what is centrifugal, Coriolis and Euler's forces, where do they apply and all that kind of stuff. So just going to kind of build upon that.
Nice. What time is it? At what time?
Should be at 8 p.m. tonight.
Cool. Gotcha. All right.
Yep. All right, later, lads and ladettes. Thanks for having us on. Much appreciated.
Yeah, man. Peace. Appreciate it for sure, man. Y'all killing it.
Yeah, thanks for coming, bro.
Thank you so much for coming in for that assist, because I was like, I'm gonna butcher the fuck out of this.
Dude, no worries. It's one of those things. It took me a couple of times to take it around the block because I was like, wait, what is it? And, I would get confused because I always try to address things on like if you wanted to go down the rabbit hole, like I'll go down with you. But then like we got so far down, it was like I forgot the point. So it's like once you stay focused with it, it's laser sharp, man. They really need their own timing prediction. Like Piezo was saying, it's going to be off by 10, 15 seconds. So like the margin of error there, plus or minus a second, really it's tight, man. It's pretty tight. So without their own measurement, they haven't even begun to address it. It just needs to be more, more people need to do it and understand it and just argue it, because it's, there's no response to it. Dude started
Well, I was
talking
gonna
about
ask,
If
like,
map
you
what's your game
projections.
theory on it? Like, as more of these
so
come out and the coincidence, which I think like has already been ruled out, but as it gets more robust, what do you think? What's your game theory, and what do you think? Where do they go from there?
Dude, they don't go anywhere. They'll just like lie. Like the current theory, right, is that the ether cosmology people like Shane, me, Piezo, etc., are handlers for Mike, and he faked the whole thing, and the timing is incorrect. They've now got a conspiracy going that we've conspired against. Like, how wouldn't all the flat earthers have to be in? No. Just the ether cosmology. We're keeping it under wraps, boys. So this is what's been proposed by quote unquote honest guys. I don't even want to get into the people and name them or anything, but like suppose honest globers that are just here in good faith doing measurements, and having a good time and trying to figure things out, are proposing this as a real explanation, just literal slander and just crazy stuff. So that's cool. That's like
hang
the
on,
best refutation we've got.
just to be clear, what they're saying is that Dr. Mike is making all this up and you're facilitating that.
No. Not only did he make it up, we're like the ringleaders of it, and we're like using him to push out the fake thing that we came up with. Is my understanding of the position that was put forward.
You guys
And this
must
is
have
by
did the
the
same thing.
Globers who
But
call
You
us
by
must have did the
conspiracy
same thing for
theorists.
Battle of the
yes,
That's
Beans
crazy.
too, huh?
yes,
Come
yes.
on, Alan. I know you got him with that $100,000 Mercedes. Come on, I know he sold out. Tell the truth.
Oh, easy money.
Yeah, Dr. Mike had himself like doxxed, like Ruhif went to his house, all this just to make up a lie.
Wait, hold
You know?
on. To be fair, Ruhif did go to his house or said that they were there yet. That we know of.
Oh, he posted pictures of his mailbox though and blurred
No,
out the numbers.
that was from Google Earth though.
Oh, so he hasn't went out there.
Yeah. He's quote
Oh,
unquote, trying to hide, like he's trying to make it irrelevant and measure the angle during the day, and it's like that's not even our claim.
I already told him. I hope that y'all can
Yeah.
explain why that would not work.
Oh, Taylor, you're so innocent. You, yeah, I'm sure he's gonna get right on understanding that. All right.
Okay, like don't
Um.
forget during the daytime things get shorter. Thank you.
Yep. All right. I'm heading out, lads and ladettes. See you guys later.
If you
I'll
want,
All
just
right, thank
before you
you.
go, sorry,
I'll keep
if
you
you want,
posted on the Heffron collaboration.
Yeah, thank you.
out of interest, sorry, just before you go, have you shown this to Jaren at all?
Nope.
It'd be
Weren't you
interesting to see
trying
what
to?
he says.
Well, we are going to do a thing at the end of the month that's going to be like there was a roundtable that was done recently on Kingdom and Context, I think. But we're going to do one at the end of the month, kind of addressing the major points that Jaren put forward as like, flat Earth can't answer kind of thing. We're going to go over the ones that we can't answer, the ones, and go over the speculation for the things that we can't answer. And then we're also going to go over the things that are mutually exclusive, like, Battle of the Beams, Celestial Theodolite primarily, because that one's even simpler to get and more people can reproduce it. But yeah, like we're going to go over the mutually exclusive things where it's like, what is the correct interpretation of the coordinate system that we're using? Is it a globe, or is it best represented by something like the AE map where it's like, flat? And the way that you would determine that would be stuff like this. So we're going to go over all of that later, at the end of the month. That'll be on the last Tuesday of the month.
All right, keep us posted because that'll definitely be interesting to tune in. That way we can stream it in here.
Yep. All right. Later.
Thank you.
Bye, guys. Thank you so much.